things were not in our hand. As I told you, some lease line of BSL got cut at some village due to some construction was going on, and we've just come to know that this will not get corrected the whole day. So we are trying to put the whole thing on Wi-Fi, because of which the speed will be a bit slow and you may not be getting audio and video of very good quality. So kindly bear with us. And today we have with us Mr. Tejinder. He is working in Iceland, and he has a wide experience in the area of robotics, and he has developed a lot of projects based on embedded systems. Today he will be taking a session on Proteus software, and since the programming, yes, since the programming will be done in Keil software, so we will also.
Hello, ma'am. I am
Yes.
clear, ma'am. We are getting disturbance in the voice.
तो डिस्टर्बेंस रहेगी मैंने एक्चुअली बताया ना कि आज हम वाईफाई के थ्रू कनेक्ट कर रहे हैं तो वाईफाई की सारी
मैम अभिलाष शेयर फ्रॉम एमआईटी।
हाँ जी
मैम मेरे ख्याल से किसी एक सेंटर का माइक खुला हुआ है जिसकी वजह से डिस्टरबेंस है।
प्लीज सभी सेंटर्स अपने नहीं माइक तो ऑफ है सर। एक्चुअली क्या है कि अभी वाईफाई के थ्रू हम ट्रांसमिट कर रहे हैं, इसकी वजह से ये थोड़ा सा आपको रहेगा आज।
Good morning, all of you. Today I'm going to explain you how to use Keil software to make the code for the microcontroller and to use simulations of microcontroller in Proteus software. First topic we will learn is Keil compiler software. And the second topic second part of Proteus software, like the simulation of circuit and the coding, using making of circuits using 8051. So the software will be Proteus. Concentrate on programming in C language. Some miscellaneous process. Go through some other controllers. Yes, they are very used in construction of circuit due to the ease of usability. These are Arduino. Maybe are microcontrollers. These are a different series than 8051. But if we are using C language, then we bother about the internal architecture while writing the code for the microcontrollers.
Hello? Sir, your audio we're getting, it's not clear. There is lot of noise. We're not getting anything you're saying.
So that's why we are typing in a Word file. So you just concentrate on Word file or check for the software use. So after the installation of Keil software, Keil microvision will appear like this. So first, when you first time start this software, you just close these all windows or delete the previous project files. So after the first installation, the software will look like this. So in order to work with Keil software, you have to follow some steps to initialize this software so that we can convert text programming into a text file. So actually this Keil compiler is an assembler come software. You can convert assembly code into a hex file, also a C code into we are going to use the C programming language. So we are going to use the word C language.
सर आपकी वॉइस क्लियर नहीं है.
due to
सर अगर सर अगर
this
आप कोई दूसरा माइक यूज कर पाएं
this voice quality is due to Wi-Fi network. This line of BSNL is down, so we are transmitting through Wi-Fi. There's plenty of problem in sound quality.
सर अभी जो मैम से बात हुई थी शी वाज सेइंग कि देयर इज सम प्रॉब्लम इन बीएसएनएल
One in using a Keil compiler project, new project. So go to project and select the new microvision project. Then we have to save this project on a hard drive. So a new folder anywhere on the drive and as a
दिख रहा होगा यूट्यूब के थ्रू देख रहे हैं ना वहाँ पे तो नहीं है सर ऐसे दिखा रहे हो ठीक है ठीक है आप देख के
एक ही पोर्ट है माइक की और स्पीकर की, एक ही पॉइंट के अंदर चार दो लेकिन वो मेरे पहले लैपटॉप में Hello. Hello. We have one green color. Select new microvision project. This new microvision project, and software will ask to save the project on a hard drive. After this project, new microvision project. Next option is to select the microcontroller. We have to select the. We have option for different manufacturer of 8051 microcontroller. Since we are working on an Atmel 8051 family, so we are selecting. We can select any microcontroller from these Atmel. We are going to select 89C51. So here we can see that the basic description of 8051. Software by default ask to say add a template to project. So generally we select no. So the first step is to create project, new microvision project, and save the project and select the microcontroller. So first step is to select the microvision project. Second step Second step is to create a file, new file, and save the same text file in the same folder. The naming of the file is an important step. We have set the format of file dot C. In assembly language, then we have to set the same format. Creating a new project, creating a new file. See here, source group 1. Step, step 3 is to add text file into project file. Select a new microvision project, save the project, create a new text file, and name it lab.c. Step is to
हो गया कहते हैं हम आप ऐसे लगे आफ्टरनून का सेशन हम नहीं करेंगे अगर आगे तो ठीक है सॉफ्टवेयर का हमारे को अपने एक्सपीरियंस प्रोजेक्ट्स बनाने हैं ना वो कैसे होगा मेरी आवाज जा रही है टाइप भी कर लो
step number 3 is to add file lab.c the project source. So add file c. Right click on the source group 1, option of add file to group 1. So see that we have a file led.c that we have created in step 2. We have to just select this file and click on step number. This is step number 3. The step number 3 is to right click on a file, add file, and add. Now, fourth step and final step. Configure the setting. This option is available by right click on a target one and select the option for target one. Select only one single setting is to create hex file. Step 4 is to configure the final setting. for habit. So in order to set up Keil software for writing a C programming, we have to do some setting. We have to configure the software. So these are the four steps to configure the Keil software. The first step is to select a new microvision project, save the project, select type of microcontroller you want to program. The second step is to create a text file. Since we have to write a code, we need some text editor. So here the text editor is a notepad file, text file, and like in HTML, we have to change the extension of a file. Like in a similar way, we have to change the extension of text file to .c file for writing a code in a C language and .asm for writing a code in assembly language. After that, we have to add text file created in step 2 to the project created in step 1. That means we have to add step 2 in a step 1. After that, the final configuration is to select the option create hex file. This option is available in target 1 click, and in output tab we have a create hex file. These are the 4 steps required every time you start the Keil software for writing code. So after setting of this Keil software, next step is to write the code. Uh, Frequency is required only when we want to do some calculations. For writing basic codes, it doesn't require. If we are using this debug toolbox, this debug option is used for step-by-step execution of code. In that case, if to check the delay, this doesn't affect the the hex file. It doesn't affect the hex file because in hex file the delay is depending upon the code we write, not on the software setting. This software setting is required only while debugging the code. For example, I have created a delay of 10 millisecond, and I write a code for a 10 millisecond. But this software will show you 30 millisecond because of that 33 setting. If you select the exact crystal frequency, you will get the exact code, exact time delay. You will see the exact time delay. But that is not an optional. Generally, we do calculation on a paper using crystal frequency that we are connecting for 11.0592. Generally, we get a time of 1.085 microsecond. From and by setting a counter, we generally calculate the delay. If I go to the Keil software, it will extend too long because using a Keil software, writing a code and debugging a code take a long time. I have to go to other steps. Main step is Proteus simulation. After setting up of these our second topic is basic tip for writing your code is always use comments. I'm starting my code with comment, and this will help us to differentiate and to determine which code is this. So here the comments start with double slash, and when I'm writing like for which the code is. You can also configure the font setting from edit, configure box, color font, C5, and the font size. ब्रेक लेना लेकिन ऐसे समय छोटा सा प्रोग्राम programming is a case sensitive language. Otherwise, assembly language is not a case sensitive. That the LED is connected to 1051. 1.0 of C language do not provide any facility for input-output operations or memory allocation. These functions, high-level functions, are provided with the help of subroutines or functions. So, in order to include input-output operations of 8051, we have to include a file reg51 register 51.h file. This file consists of another C program that provide input-output operation. Actually, it's a kind of function written in another source file. First step is to register 51. And since we have connected the LED to P1.0 of 8051, we can toggle all the pins of 8051 using a basic command. The most very basic command is P1. C is a case sensitive language. We have to learn, we have to memorize the some syntax of the C language. Port 1 is always accessed a capital letter P1. The valid or P1 is not valid. So in order to send a hexadecimal data port, we have to use 0x. 0x stands for X. Using the line P1 equal to next is to turn off the LED using P1. If we want to open the LED one at a time, so let's select the statement structure, file structure. This allows to execute. Check whether this code work or not. We have two options. One is to debug the file, debug the code. Another option is to simulate this code on a Proteus software. But before doing simulation, let's go for the debug option. This is available in the right side corner of a Keil software. With the red B symbol, debug. Debug, we have to combine the code, down arrows to combine the code. We have to go to the functions. Okay, sir. He explained here. In software. In simulation. Simulation. Previous lecture we have learned how to write the C program, and so we have to go to the next step is to create a simulation file, simulation in Proteus using this soft based C language and hardware. So in order to debug the code, select the debug. Here on the left side, you can see various registers present in the RAM of 8051, R0, R1. These are the SFR, special function registers. Since we have sent data on ports, so we have to go for input output ports. In order to debug the code, we have to press F10. In the debug, you will see the right side. You can execute line by line, and you can also check the time taken by a single line to execute the code. In order to check the correct time, you have to set the frequency to the crystal frequency. Otherwise, you will see the wrong time. If you want to check how much time this code will take to execute, this can be checked using only debug option. And for that, you have to set the exact crystal frequency. You have to match the crystal frequency with hardware. When this is matched, you can check the exact time. On the left side. See, starting again. initial this option will give you the time option. When I execute the first line, the time is incremented. 194502 19550. This much time this code has taken. This is for crystal frequency of 33. If you set the different crystal frequency, here you can check the time. For example, you have created a function of delay to generate a time delay of 1 second. Then how will you check? This is the only option. Or second option is to do calculation on a copy. Since you have learned the basic codes, I'm assuming that you know how to write code, and I'm shifting to the next part is to do the Proteus simulation. Okay, so this is a basic code to write to blink the LED. This is our a delay function, and this is a main function in which we are calling the port P2 on and off after a few millisecond delay. Okay, so this is a very basic code. So next step, Proteus. When you first time start the Proteus, rest we continue after tea break.
Hello, am I eating? Hello, hello, can you hear us?
जी मैम
हमारी आवाज आ रही है?
हाँ मैम आ रही है, थोड़ा डिस्टरबेंस है लेकिन हाँ क्लियर है।
Hello,
हेलो।
हेलो, हाँ जी।
ma'am. I'm from Dronacharya, Greater Noida. Your voice is not clear.
Actually, the thing is that, as I told you, that BSNL lease line has got cut, and because of that, we have put the whole thing on Wi-Fi. And what we are doing is कि आप थोड़ा सा पास में भी कर लीजिए, and हम ना इसको साथ साथ में लिख भी रहे हैं। वो जो जो कुछ भी बोल रहे हैं ना हमारे एक्सपर्ट, वो साथ साथ में लिख भी रहे हैं, और क्लास खत्म होने के बाद मैं आपको मेल भी कर दूंगी। एंड आई विल रिपीट द सेम टुमारो। मैं कल की क्लास में अपना ये सारा आपको दोबारा से करवा दूंगी।
Okay, ma'am.
हाँ, वो भी एक प्रॉब्लम हो सकती है सर। ये हमारा एक्सपर्ट का लैपटॉप है ना सर, क्योंकि सॉफ्टवेयर उसमें है। वो माइक इतना इफेक्टिव नहीं है। आज आफ्टरनून तक है सर। होता भी है ना वो, तो ये वाली वायर इतनी लूज है कि 2-2 मिनट के बाद ये ब्रेक हो जाती है। कल मेरे लेक्चर में तो पूरा दिन यही रहा। तो मतलब शुरू करते हैं तो वो ब्रेक हो जाता है। इसकी इसका तो सर मुझे नहीं पता, इसका तो मुझे नहीं पता। मैं तो इनको ही बोला था। बाकी आज तो सब BSNL को फोन किया, वो कह रहे 3 बजे तक नहीं हुआ। ठीक है। यस सर। बहुत करवाना था
हेलो
पूनम मैम के लेक्चर में।
हेलो MIT मेरिट एम आई ऑडिबल
वापस चला जाता था 4 दिन एसी ठीक करने के टाइम नहीं मिला था।
एम आई ऑडिबल सर आपको अब कोई प्रॉब्लम आ रही है
टी टाइम उनका भी टी टाइम है, छुट्टी उनकी भी छुट्टी है, एक सेकंड सुबह आ जाते हैं बच्चे जाते हैं।
सर ऑडियो में अब कोई प्रॉब्लम है एनी ऑफ द सेंटर कैन रिप्लाई
हाँ मैम MIT मेरठ बिल्कुल क्लियर है आपकी ऑडियो।
आवाज क्लियर आ रही है मैम?
ठीक
हाँ
है
ये ऑडियो
उनके
बिल्कुल
लैपटॉप
क्लियर
में
है।
प्रॉब्लम है मैंने कहा है मैम आपको वो लैपटॉप का इशू है
हाँ मैम वो मेरे ख्याल से लैपटॉप के माइक में ही उसमें ही रिसीवर में ही माइक्रोफोन में कोई इशू है।
वैसे यही बोल रहे हैं कि वो लैपटॉप का इशू है
अगर एक्सटर्नल माइक यूज करेंगे तो मेरे ख्याल से सही आएगी आवाज।
Speaker mic. Hello, hello.
नहीं डाउनलोड नहीं करना, मैं वही तो बता रही हूँ। वो तो मैं भी अपनी इसमें से कर लेती डाउनलोड। अब हम क्या करें, इन्हीं का ही लैपटॉप यूज करें सॉफ्टवेयर का, और उधर का हम वो कर रहे हैं। वो हो गया अभी फिलहाल के लिए। आपके पास है सर सॉफ्टवेयर? देखे आया नहीं तो इनके पास है ना? आप सबके पास है?
Proteus है ना? कोई पर्सन क्या है? Proteus के बीच में ही अपना एक कंपाइलर भी होता है, तो आपको कील लिखने की जरूरत नहीं है। तो दो विंडो खुल जाती है Proteus में, एक सर्किट की और एक कोड की। जो कोड लिखोगे वो उसी में। तो अदरवाइज हम कील से एक्स फाइल बनाते हैं और दूसरे सॉफ्टवेयर से ब्राउज करके सिलेक्ट करते हैं।
यस सर। Proteus से करवा दीजिए डायरेक्टली, कि एक्स फाइल से क्रिएटेड है ऑलरेडी। Hello, can all the centers hear us now clearly? Because we have changed the system. Can we have your response, please? Can you hear us clearly now?
Hello, ma'am.
Yes, ma'am.
Ma'am, I'm from DGI Greater Noida. We're getting your voice clearly.
Clear. ठीक है, ma'am. Thank you. Now we are going to start with Proteus directly, and those who want to learn Keil, I would like to tell you that tomorrow I'm going to take dedicated sessions on Keil in the morning class.
Okay. Okay. So first of all, we have to start the Proteus software. So we have Proteus 8, and but the first time you start the Proteus, you will get this kind of interface. So here we have some few steps. First step is to create a new project.
इसको हम zoom कर सकते हैं किसी तरह से इस विंडो को?
इसके लिए मैं
वो होता है ना, वो मैग्नीफायर।
हम पर वो कर्सर नहीं आएगा। So first step is to create a new project. So we have a option to save this project. Next, replace existing project. Yes. Then uh, in this tab we have to select create schematic. If and these are the default templates, and go for the default template. Next. And this is the main and important step. If we want, we can create a simulation in both these two options, but if we select create firmware project, Proteus will automatically select the type of controller and automatically select the compiler. So Proteus have their inbuilt compiler ASEM51, but we can also use third-party compilers like Keil for the 8051, and we have 8051 assembler, and we can also attach Keil software with this Proteus by selecting the compiler option. So we can attach or integrate Proteus with Keil software. Okay. So here we are going for default option ASEM Proteus. So next. Next. Finish. So when we start with project, we'll get two types of window. The first window is schematic and another is source code. So leave the source code window, and this is the 8051 microcontroller we get from the library. If somehow we delete it, we can also select the different devices from the left side option. On the left hand side, we have a triangular shape icon. By selecting this component, we enter into the component mode, and when we click on the P icon, we will get the list of the devices available in the library of Proteus. Since 8051 belong to microprocessors, so we have to select microprocessor, and in drop down further subcategory, select 8051, and further we can select different manufacturer. Select any microcontroller related to 8051 family. 8051. This is the same pin diagram that we have studied in the books. It's actually a pin diagram of 8051. We have 4 ports, P1, P0, P2 and P3. These are the control pins. Okay. And from the same left side menu, we have terminal mode. From terminal mode, we can select the power supplies like ground, VCC. We can change the value of VCC.
By default, it is +5.
That we have to check. It's not mentioned.
So we have to mention it.
Using a Proteus, we can check only a 90% of our circuit. Rest 10% of troubleshooting we have to do on a real-time hardware. So there are some constraint, like if we do not connect power supply, microcontroller will work. This kind of option is available from the properties of device. For example, right click on microcontroller and select edit properties. Here you can see that we can have option to mention the frequency. So after setting this frequency, we do not need to connect crystal to the pin number 18 or 19. Even we can see that these 40 pin ICs do not have ground and VCC pin because these are already connected to the ground and VCC by default. Okay. No. Actually, these are hidden pins. Pin number ground and VCC. In some libraries, we have an option for ground and VCC. So this software will assume some default values, like we need ground and VCC, VCC's crystal. So these basic configuration we need every time. So this software will automatically provide the dialog window to configure this parameter, like clock frequency. And in the properties of 8051, we have an option to select the program file or hex file. We can browse a hex file that we want to load into the 8051. Since the first program we have write is to blink the LED, so first of all, the first step in making a circuit with Proteus is to select the all components that required to construct the circuit. We have got the 8051. The next is to get the LEDs. So first we have to enter into the again component mode and then select device. Go to the optoelectronics, and in optoelectronics go for LEDs. Then here we get different type of LEDs like blue, green. These are the just symbol, not in simulation, and these devices work in simulation mode. These are active. We can also change the parameter of these LED, like forward bias voltage, current, and the type of application, analog or digital. and we also need one resistor. So same again in component mode, select another device, or you can search it, resistor. In actual hardware, we have to connect this 31st pin to the VCC. But in simulations, the basic circuit required to boot the 8051 are not required. We have to just connect the input-output devices and upload the code. Like ground, VCC, crystal, reset, circuitry is not required in order. And if we do not connect these external component, the processor of computer will suffer more load due to these. If we connect these external component, then the load on the simulation will be less, because this operation is performed by the software. We are connecting LED in active low configuration. That means active high configuration. When we get high signal, LED will get on. Changing the parameter of resistance of resistor. Now we need ground. In this case, we need ground option to connect the negative terminal of LED to the ground. Since the ground and VCC pin of 8051 is hidden, so we have to select external ground. This is an important option available from terminal mode. We have ground. So this is the simplest circuit you can design in Proteus. Now let's select the hex file created in Keil compiler. Right click, edit properties, files. Here you can see that blinking of LED, and we can also see the status of port 2. The other pins are also blinking. In this case, the CPU load is 4%. Now let's check this CPU load if we connected external crystal, reset, and other circuitry required to build the hardware. These, in real time, these circuitry are required. So
first, let us ask all the centers if they were able to understand what are the all steps to build the circuit. Does anyone have any problem? Is it clear how to create a circuit and run it? Yes, I'm not getting any response.
Hello, ma'am. I am from NIT. Please repeat the process of Proteus once again.
Was it not clear?
Will you please repeat this?
Okay, एक बार दोबारा से circuit बनाओ. Okay. एक काम अभी वो दोबारा से बना दो with components. Okay.
So I'm deleting this old circuit. So in order to delete the present circuit, first you have to stop the simulation. Then you will enter into component circuit editing mode. Then select and delete the component.
स्टार्टिंग से बता रही हूँ तो विंडो ओपन करते हैं तो क्रिएट न्यू प्रोजेक्ट्स
Okay. So starting with Proteus. I'm going to repeat the steps required to generate a simulation file in Proteus. So the first step is to create a new project. And you can rename the project or use it as it is. New project. Then you will get the option to create schematic. The circuit in which we connect different components is known as schematic. The circuit that we have seen in books is also schematic circuit. The other type of circuit file is PCB file. In this case, we do not need any PCB file. We need schematic. Here, do not create PCB layout since we are not designing PCB of the circuit. We are just only using the schematic circuit for simulation purpose. So select do not create PCB layout. Next. And in this step, I'm using no firmware. So I'm going to create a blank Proteus file. Next. Finish. So using this steps, I get a blank Proteus file, and now the next step is to collect the all discrete component like resistance, capacitors, LEDs, microcontroller, and connect these discrete component together to make schematic, and then upload a program file into the circuit and check the working of this circuit. So the first step is to collect the all discrete component. So entering into component mode by selecting this second triangular IC and click on this P button. Go for capacitors. Again, select another capacitor. You can change the value of these capacitors. 33 GF. These capacitor I'm going to connect on the crystal oscillator. Now next is to select the crystal oscillator. You can change the orientation of the component using their right click option. Now we need more components like resistor. We need some electrolytic capacitors. Next is to select LEDs. Before doing the simulation, we must know the components required to create the circuit. Simulation is for those who know how to create the circuits. It is not uh, for learning the electronics, it is for doing the electronics. So I'm assuming that you know the basic components required to boot the 8051. So the basic circuit is here a crystal oscillator circuit and the reset circuit. Now next we need 8051. You can choose any microcontroller. For basic operation, it doesn't affect your circuit. Now we need ground and VCC. So this is the main reset circuit required for the working of microcontroller. In this reset circuit, we have used 10 kilo ohm resistance and 10 microfarad electrolytic capacitor. And the center of this is a time constant circuit, and the output of this time constant circuit is connected to the 9th pin of 8051. You can easily drag the whole selection for better representation of circuit. Next is to connect crystal to the 18th and 19th pin of 8051. We can rearrange the circuit for better presentation. And here we need ground. In this circuit, I have used two different ground symbols, but technically these are connected to each other. You can also make wiring like this, but this makes circuit look more complex. You can create circuit in modules. This is crystal module, this is reset circuit, and this is a clock generating circuit for 8051. So the two parts are completed. First is reset circuit, another is crystal oscillator circuit. Now In real hardware, we also need to connect 31st pin, that is external SS. We have to disable the external SS so that microcontroller can access only internal memory. We need to connect it to the plus 5 volt. Now the basic circuit required for booting of microcontroller is done. Now we have to connect external peripheral that we want to drive. In this case, the first peripheral we are driving is LED. So I'm connecting LED to the port 2. And we also need another ground. The next LED I'm going to connect in active low configuration. In actual hardware, I will prefer active low configuration so that we can get maximum current from the source. And here I am leaving the resistance with the value of 10 kilo ohm, and let's see the effect of this higher resistance on the working of LED. The next step is to select the. Here I am using the crystal frequency 12 megahertz. So you can see that only LED connected to 21st pin is working and LED connected to 25 pin is not working because the resistance connected to LED is too high. Change this resistance to 10 ohm and change it. Again, LED is not working. Stop the simulation and change the resistance value to 10 ohm and again run the simulation. Like you can see that the effect of resistance that we face in real hardware circuit. In some cases, the Proteus will not work as hardware work in real time. There are some constraints that you can learn only by doing with Proteus. So the first part of completing, first part is complete, in which we have connected LEDs to the 8051.
Any doubts? Any doubts? Can we have some answer from our centers? Does anyone have any doubt?
No, ma'am.
So can you tell us why
No,
is this reverse? Can you tell us why is this reverse happening in D1 and D2? When D1 is glowing, D2 is not glowing. Why is it so?
Because that another end of ma'am, this is from MIET.
Yes, sir.
Ma'am, because another end of this R3 resistance is connected to supply.
Hmm.
So if you send 1, then it will not glow. If you send 0, it will glow.
That's
Is it?
right. So it's very important that you have to see in which configuration you are connecting your LED. It is very important.
Otherwise, we have to
Otherwise, you have to change the logic.
You have to change the logic, yes.
see the LED D1 is connected in source configuration. The first configuration is called source and second configuration is called sink. In first case D1, the LED is extracting current from the microcontroller. In real time, if you construct this hardware, you will see the D1 will be less brighter. In second case, the diode is extracting current from the power supply, and from power supply we have infinite current. In ideal case, so LED will got maximum current and work with full efficiency.
Question was that why is it that D1 and D2 are blinking in opposite, like all the so configuration बहुत important है.
Current source sync is less as compared to current sync.
We generally used microcontroller as a sink, not for source. If we used microcontroller as a source, then microcontroller will get reset or their pin get damaged. If, that's why we always connected switches to the microcontroller with common ground. That make it is a load. We always connect load in a sink form. You can also check the sink and source current rating of the microcontroller from their data sheets. Sink is always greater than source. So in next step, I'm going to connect.
And check also that अभी CPU पे कितना load है. पहले 4% था ना जब हमने वो
Actually,
करके देखा.
the 4% is with single LED.
एक बार इस LED को remove करके जरा load देखिए कितना बनता है.
6%.
So load बढ़ेगा.
Resistance पे
330
इस पे लोड पे फर्क पड़ता है. कुछ सर्किट्स में हमें ये लोड मिनिमाइज करना होता है, अदरवाइज प्रोटियस हैंग होता है. लोड मिनिमाइज करना होता है. Next is the next. I'm going to interface a 2x16 graph character LCD with 8051. So I'm using the same circuit and I'm going to connect LCD to the microcontroller. So we have to select the LCD from the component mode P and select the optoelectronics.
LED, LCD, etc. All of these are in the optoelectronic category.
alphanumeric LCD 2x16. Yes. No. We have to select alphanumeric LCD. You have to go to alphanumeric or just type 2x16. 2x16. So LCD have 8 data lines and 3 control pins. And these are the power supply and the contrast control of LCD. So in similar way, first we need ground for the first pin and VCC for the second pin. And again a resistance to control the contrast of LCD. Third pin of LCD is connected to ground through a resistor. So we require one resistor, ground and VCC to power up the LCD. You can see that if you run the simulation without connecting data lines and control line, LCD will power up. Now, the connection of LCD to the 8051 depend upon the code. So you need to know pins described in your code for the proper functioning of your circuit. So I'm assuming that you have previous knowledge of coding. So I'm going to use my sample code. So this is a code of a LCD, and these are some declaration I have used.
So this is the same code which we discussed yesterday. The only difference is that in this case, all your control lines, they are connected to port 3, as you can see here. The RS pin, which is used to select either the command register or the data register, it is connected to pin number 3.2, and read connected to pin 3.3, and enable pin which is connected to pin 3.4. So it's very important that all your hardware connections should be according to this configuration only. The rest of the code is the same which we did yesterday.
Data pins to
port 1. Port P1 only.
This is the address of port 1. So 3.2. Register select pin 3.2. Read write. Enable to 3.4. In Proteus, if you select just input and output of a pin circuit, software will automatically give the path to the wires. So you don't need to worry about the misconnections. and I'm generating a hex file. And this code is used to print only D word on an LCD. I'm sending data D in this code. You don't need to update the hex file. It will automatically get updated when you change the hex file from compiler. We don't need to select a hex file again and again. It will automatically get updated. So here we are getting letter D. If I change the code to E and recompile the code, rebuild the code, and stop the simulation and run the simulation again, we'll get the letter E.
फर्स्ट टाइम तो आपको कोड जैसे आपने एलसीडी के लिए तब तो चेंज करना पड़ेगा कि आपने नाम सेम ही रखा था उसका
किस चीज का?
जैसे पहले आपने एलईडी का कोड जनरेट किया था ना एक्स फाइल जनरेट किया था तो
मैंने उसके ऊपर एक और कोड पेस्ट कर दिया वो।
अच्छा अच्छा उसी वही बोल रही हूँ मैं एक्स फाइल का नाम सेम ही रहा तो वो ऑटोमेटिकली जो उसकी मेमोरी में है वो वही रखेगा।
Now I'm going to write some another LCD code with some modification. In this code we can print strings, and here in this code the connections are same, but I have used some function, string function I have made.
String function इनको बता दो C program में।
In string function we can process with a string. In this is the function name is LCD_string. This is the argument of a function. This function will send this argument or this data to this function LCD_string, and the variable used to store string is unsigned character, and this string is then stored in the form of array. Then this loop will run for the, since our size of LCD is 2x16, maximum string we can print on a LCD is 16, so we have to take care while writing the string. Since welcome is a 3, 4, 5, 6, 7, 8 including space, 9, 10 character long, so this string is sufficient for the first line of LCD, and iter is a 6-word letter.
So we have to write it in the second line.
Second line.
That is why yesterday we discussed, na, in case we want our cursor to the beginning of the second line, it should be C and then whatever position you want. So that is why iter is to be written on the second line. So that so LCD command C5 has been written.
And this function will extract the each index of the array, and the same function LCD.data will display each character one by one. But this function will allow us to make code easier. Otherwise, we have to send each single alphabet one by one. This code is just like using a db command in assembly language. So I am again recompiling the code and generating hex file. I am stopping the simulation, and again we can see that we can also alter the position like iter. We can change the C5. If I change this to C0, so with the help of Proteus, we can check our code and hardware, because when working with microcontrollers, we have two options. Either error will be generated in code, or either error is in hardware. So we have to remove the one case. First case is doing simulation. By doing simulation, we get to know that our code is correct. So there may be some error in only hardware. So we can go for the hardware troubleshooting, not for software troubleshooting. This makes process of embedded system development easier and faster. Motors का direction का clear नहीं होता.
So what are the difference? What are the addresses of this first line and second line?
Address for the first line is 80, and the second line is C0.
इसलिए पहले जो C5 था तो सेंटर में आ गया C0 को वो आपका जो कमांड है ना इसकी हेक्स कमांड उसमें दिया हुआ है टेबल में
ये शायद कुछ कर सकते हैं ओके सर इसमें शायद इसका डिफरेंट
वो आप जब LCD डिफाइन कर रहे हैं जैसे अल्फा न्यूमेरिक LCD आपने D2/16 उसका कमांड कोड सबका कॉमन है.
If somebody want to interface some sensors or some modules available in market with microcontroller, then we have to load the library of that module into the library of Proteus.
Can you tell that? How is it done?
For example, by default, if you install Arduino, you will not get any Arduino board available in the component. If you type Arduino in the search, you will not get any Arduino components. So for that, we have to download the libraries from the internet. Here's some examples.
जैसे आपका एक एग्जांपल था जब आप पूछ रहे थे अल्ट्रासोनिक सेंसर की आपको प्रॉब्लम आ रही थी तो इस तरह से है
अल्ट्रासोनिक की
तो वो टाइम आउट इशू आ रहा है.
Actually, I also said कि there's some constraint in ultrasonic. How you can check the distance? Practically, I can show you. I have made this circuit, but the code I have written in assembly language for the ultrasonic sensor. Assembly. Then I will explain you after this.
क्लास के बाद आप सुनिए. मैं एक पूछ रही हूँ कि जैसे इसमें सेंसर्स अगर हमें इंटरफेस करने हैं तो वो कैसे कर सकते हैं Proteus में?
So entering into the component mode, going to the this now search for the Arduino. Whenever you add any extra library from the internet, this library will always appear in miscellaneous option. In component you have miscellaneous option, and that miscellaneous option you will get that additional libraries. And here is Arduino, and I have Arduino Uno, Mini and Mega. These are third-party libraries. Like this is the Arduino library, and we also have ultrasonic. No, it doesn't. It does not depend upon the version of Proteus. You have to install the library.
Libraries install करनी पड़ेगी.
You have to download the zip file. Actually, these are DLL file and LIB file, library file and model files. You have to paste these two files in the C directory where software is installed. Then you will get these options.
Same folder में जहाँ पे
installation हुई है वो you have to paste that library in the installation folder. When you download libraries from the internet, they will also give you a note how to install these libraries. So simple. These libraries are available from the website of Proteus. Arduino, and yes, many more library. Library for
So any doubts from the participants? Do you have any doubt till now for all which has been carried out about the Proteus software?
see, we have libraries for GPS, PIR sensor,
So यहाँ पे सब
ultrasonic.
externally मतलब
डाउनलोड
download
करके पेस्ट कर। इसकी भी ये जो प्रोजेक्ट में आता है
Hello, ma'am.
Yes, sir.
I'm from NIET. Can we get the schematic circuits that you are drawing on Proteus so that we can practice?
Yeah, I will mail you.
Please email.
I will,
Yes, sir.
I will mail you.
We will send you more circuits. We have more examples.
There are some more examples also on the Proteus. I will send you that also.
Okay. Please send the C file also, program also.
Yeah, program also I'll send.
Okay. Thank you.
Any other centers you have any doubts? एक सेंटर करके पूछते हैं बोलना चाहिए
Arduino की simulation दिखानी है करके.
Arduino. Are you interested in the simulation for Arduino? Are you interested in the simulation for Arduino?
Yes, ma'am. Please. You can show the Arduino simulations.
Okay.
Okay. So again, I'm creating a new project file. Next. So now I'm going to explain how to interface LCD with Arduino microcontroller. The programming for Arduino's microcontroller is very easy as compared to 8051 because of the ready-made library. So first of all, again I need LCD 2x16. This is LCD 2x16, and another I need is Arduino Uno. First of all, power up the LCD. इसका हार्डवेयर भी बताता हूँ शो ग्राउंड. तो वोल्टेज पे डिपेंड करता है और करंट पे. 330 ओम इज सफिशिएंट. 1 किलो ओम तक रेजिस्टेंस लगा सकते हैं. Now I'm going to connect LCD in a 4-bit mode. This LCD 2x16 can work in two different modes. One is 4-bit mode, another is 8-bit mode. In previous mode.
Hello, sir.
Yes.
Can you can you please point out from where to find this Arduino Uno in library?
Okay. See, if you want to work with Arduino in a Proteus, you have to install the Arduino libraries from the. You have to download the Arduino library from the internet, and you have to paste that downloaded library into the installation folder of Proteus.
Sir, in your
Okay.
software, it will not be available right now because this is not Proteus में default नहीं है Arduino. यही इससे पहले हमने बताया था. लेकिन अगर आप चाहते हैं कि कोई ऐसा external libraries आप अपने Proteus में use करना चाहते हैं तो आपको उनको पहले download करना पड़ेगा इंटरनेट से और same folder में रखना पड़ेगा जिसमें आपका Proteus stored है. तब आएगा. इन्होंने ऑलरेडी डाउनलोड किया हुआ इसलिए इनका यहाँ पे दिख रहा है. आप बाद में इसको लोड कर सकते हैं या फिर हम इनको लिंक भेज देंगे. We'll send you the link also for downloading the libraries.
Okay, thank you.
Okay. Now, in order to interface LCD with Arduino, we should know the programming of Arduino. So I'm going to open an Arduino development environment. Like Keil, this is another software. This software is used for AVR microcontroller. So actually for Arduino. So you don't have to learn any programming still. You can just go for examples. Go to the example of Arduino. These examples are by default available in the Arduino. Go to the LCD liquid crystal. Here you can see that there are various examples by default available. I am selecting hello world or a display. So this is a pre-written code.
I think it was not a very good idea to show this next. We are teaching them programming.
We can teach the code even. It's a simple code. But here I am concentrating with Proteus.
Of course, programming programming सीखने की
should be a separate Arduino.
Arduino हमारा अलग होता है अलग STC ही होता है.
So let's just write the code for Arduino.
Exactly.
So
Simply load भी कर दो.
So you can see that the code for the Arduino.
Actually, those who are interested in Arduino programming and all, we have a separate course on Arduino also. तो आप उसके अंदर और ज़्यादा डिटेल में ये सब चीजें समझ लीजिए. अभी आप सी के ऊपर कॉन्सेंट्रेट कीजिए.
Here the library, this is the liquid crystal library. These are the default library available in the Arduino, and this is the function used for library, and these are the arguments. The first two arguments define this 12th pin is register select pin. Another next pin is enable pin. Read write is connected to ground, and these are the 4 data pins: D4, D4, D5, D6, and D7. Just connect the LCD to these pins 12, 11, 5, 4, 3, 2, and type the message LCD print hello world. It's a by default example, and compile the code. So we have connection to the 12, 11. Register select pin is connected to the pin number 12, and enable pin to the 11. and D4 is connected to ground. These are the pins required for minimum pins required for the working of LCD. So these are the connection are complete for LCD. Now in Arduino software, compile and have to generate the save the file on a desktop. So, CD tools, export compiled binary file. Compiling. So in similar way, you can write program in C language in Arduino, and you can also check the simulation using Proteus. Should I demonstrate the ये किसी का ही हार्डवेयर है कोड हार्डवेयर.
So now since you have already seen the simulation part, एक थोड़ा सा डेमो ले लेते हैं हार्डवेयर के ऊपर. The same apparatus को अगर हमने हार्डवेयर पे बनाना है तो किस तरह से?
No, now I'm going to demonstration of the same Arduino based circuit in real time, but in this hardware I have connected the Arduino pins LCD to the different pins of Arduino. ये तो है इसमें काफी मॉड्यूल कनेक्टेड लेकिन LCD वाला पार्ट में एक्सप्लेन इस पे कैमरा फोकस करें.
कैमरा हो जाएगा.
वॉइस तो जाएगी ना?
नहीं इससे जा रही है.
कंटिन्यू है वो स्टैंड बाय. So this is a hardware of a. In this hardware, we have connected a memory card and GPS, but we are just considering only interfacing of LCD with a micro Arduino. In this case, the register select pin, the pin number, this orange wire is a pin number register select pin. It is connected to pin number, or not? The pin number is this orange wire is connected to pin number 2 of Arduino. This is connected to pin number 2 of Arduino. So we have to change the register select pin in the coding to pin number 2. So in coding I am changing the register select pin to the 2, and read write pin is connected to pin number enable pin number 5, and data lines are connected to 6, 7, 8, 9. 6, So I'm going to print this hello world.
इसमें contrast आएगा तो दिखेगा
वो कैमरे से फोकस कर ब्राइटनेस कंट्रोल नहीं इससे फर्क नहीं पड़ेगा नहीं फर्क नहीं पड़ेगा मेरे पास
चलो आप कर दो
ओके एक मिनट ये उसको दिखानी पड़ेगी अगर ये उसकी अभी आया था जब आपने ऊपर से हाथ किया था ऊपर से हाथ किया था जब आया अब आएगा वो नहीं
चलो कोई बात नहीं वैसे इसमें डिस्प्ले नहीं हो रहा बट एक्चुअली इट इज शोइंग
सर ये ऊपर से ये हटा दो ये तो
अभी
इसको टेढ़ा भी कर सकते हो ना एलसीडी को मतलब इसका व्यू ऐसे चेंज करोगे अगर आप ऐसे तो फर्क पड़ता है
वो पीछे डायग्राम से घुमाया था ये और आ
ये ऐसे इस एंगल से व्यू को फर्क पड़ेगा ये इस पे उसमें कैमरे में ऑप्शन होता है शायद एक
तो और भी ज्यादा होगा
फिर एक ऑप्शन
वो आया बीच में आया था थोड़ा ये
ऑप्शनल लाइट ऑन कर दो
नहीं मत करो कोई बात नहीं उसमें लाइट है
ये इसकी अपनी लाइट की इसकी वाली लाइट की बात करते हैं बस येलो लाइट बंद हो गई दिखाई दे रहा
हाँ आगे
This is different code available in the microcontroller. I am uploading this code. Hello. I've changed the code as
so now we have come to the end of today's lecture. Thank you so much, Mr. Tejinder, for giving your valuable time to us and explaining in detail how to program in the 8051 in Proteus, as well as one demonstration was also given on Arduino. And in tomorrow's class, I'll be telling you about how to write your code in Keil compiler and how to create a hex file. Apart from that, there will also be some demonstration on 8051 based kits. Some of the programs which we have already done in the class based on LCD, LED, we will be demonstrating on the kit. And apart from that, I will also show you how to interface DC motor and stepper motor with 8051. So let me hear from the different centers in case they have any doubts, and then we'll close for as of now. NIT Greater Noida. Any doubts? NIT Greater Noida.
Hello, ma'am.
Yes, sir.
Ma'am, no doubt so far, but please send those files. Email the files.
Surely I'll send them. Dronacharya Group of Institutions, Greater Noida.
Hello, ma'am.
Dronacharya. Yes, ma'am.
Ma'am, we have no doubts from here.
हाँ जी बताइए. No doubts बोला कि some doubts बोला? Some doubt. Yes, ma'am. Please tell.
Ma'am, we have no doubts from the participants.
No
Thank
doubts.
you.
Okay. Then we have MIT Merit.
Thanks a lot, ma'am, for the session, and we do not have any doubt. We have no
Okay.
doubt.
MMU Mulana.
Ma'am, no query, ma'am.
Okay.
No doubt, ma'am.
Dronacharya. Okay. Dronacharya Group Gurgaon.
Thanks, ma'am, for the nice session, and we don't have any doubts till now. Thanks a lot.
Okay. Thank you to all the centers for cooperating with us. Since morning we have had some glitches in the internet, but still we got very nice cooperation from all our centers. I would like to thank you for that. And thank you, Mr. Tejinder, for your very nice demonstration of the Proteus software.
Thank you.
And now again we'll meet at 2:30 for the next session, which is Industrial Applications of Microcontrollers. This session will be taken up by Dr. Baban Kumar, whom I've already introduced to you, and he will be telling you about all the projects the scientists make based on microcontrollers. Thank you so much.
Thank you, ma'am.
ओके
मैं आपको मेल कर दूँ.
आप मुझे मेल कर दो सारे प्रोग्राम्स भी और उनको मेल Industrial applications of microcontrollers. Which all projects are going to discuss? We have with us Dr. Baban Kumar in this session on industrial applications of microcontrollers. He will be sharing with you all the projects he has successfully executed as project leader during his research experience of 15 years based on various microcontrollers. The various projects are mainly based on food security, water quality, etc. So, आप इधर ही आ जाओ, इधर ही आ जाओ.
So, good afternoon all, and I hope I am audible and there is no issue, technical issue as far as the listening is concerned or visibility is concerned. And so today this is actually real world industrial applications, we can say, of embedded systems or microcontrollers, and that is the brain that is central core to the embedded systems. And I think I'll just put some few questions and just explain few things which are very important as far as the real world applications, industrial applications are concerned. Some basics, what are the efficient ways of designing the embedded systems, etc. And then we will straight go to the applications that we developed. So what I believe is actually whatever we learn, whether and there are a lot of science we do, a lot of research we do, we have a lot of learning, etc. But I think unless it meets a goal of some purpose, it's of no use. So unless that technology meets the purpose of real world challenge, solving some challenge, some problem, it serves no purpose actually. And that is what these embedded systems are meant for. They actually are meant to serve a particular goal, particular task, and that is what the aim of anything that we do in life is. So this we have already seen that what is microcontroller, and I think by now we all of us are aware of it, what this is about, and how it differs from the processor, what makes it a complete controller. So there are different blocks that are added to the processor by the same design engineer team, which makes it controller. And just I will put you a small question that what do you think? Why these all blocks which are external to the processor are connected through a common bus system? There are three common bus systems. I mean, three buses are there: address bus, data bus, and control bus, and through which these blocks are connected, which makes it a complete controller. What do you think? What are the underlying motivation or inspiration? Why it is done so? There's not much technical about it, but there is some small common sense that goes into it. So, any center? That way I'll be able to also check whether you are able to listen to me and whether we are able to interact with each other. What do you think that why these all blocks in the controller are connected, like RAM, ROM, etc.? Of course, there are a variety of architectures also, Harvard architecture, Van Neumann, and this Princeton. So what do you think why these blocks are connected together through a common bus system? There are three common buses that these blocks are connected through. Okay, address bus, data bus, and control bus. Any one center? Do I have to name the center or the MIT Meerut? Can you tell why do you think why these blocks are connected in case of microcontrollers through a common bus system? These buses are common to all the blocks, right? RAM, ROM, or peripherals and processor. They are connected through a common bus. What do you think? Why it is so? And as I said, there is not much technical about it. There is some common sense also that goes into it, and there is little bit technicality also. And obviously, design engineers thought about technicalities only, and they actually made it a common bus system. So I'll just explain. There's nothing special about it, but the main motivations are basically to keep the pin count down and to keep the expandability easy. Because you see, just imagine, had there been all the blocks having their own data bus, address bus, etc., that would have resulted into huge footprint, huge, okay, and that would have increased its all size also, PCB size or pin count size and IC size as well. And secondly, whenever you want to have some additions like GPS, okay, you want to have some GSM, anything. In real world, basically all these controls are meant to interact with the real world. So your requirement may be having addition of GPS or wireless sensor module, Internet of the Things module, or LAN module, anything like that. So to have that kind of expandability, you need to have this kind of common bus system. So it will share same kind of memory mapped architecture. That was all about that, and so this is how that controller looks like. You know, we have added different blocks, and now it is ready to take up. And now why I'm showing this all, because in industrial applications you will have to think about customizing each block. Why, how should be the RAM, what should be the ROM, and what should be the peripheral input output devices. So what should be these be the configurations, what are their specifications. So once you are ready with your technical specifications of your industrial application, you should be knowing now what cores you should be selecting, and for that matter all the industries, they all the manufacturers of the controller, they supply the relevant different parts or these cores or controllers available from them. Now so this RAM, basically it should have been both-sided arrow. RAM, because it reads and writes, and this arrow should have been at ROM. Basically from ROM we only read, so the arrow is pointing to the data bus. So this is how this actually bus system is connected, and that makes it. Now another important aspect as far as the industrial applications are concerned, because whenever you will go for any development or building any product, industrial product or any application like that, you will have to come across this one of the important aspect, that is selection of a controller. And how do you do that? So for that matter, it will be worth watching that and knowing that there are different types of controllers available in the market from the variety of manufacturers. And you see, they say that need is the mother of invention. So all of these controllers actually have been existing because of that need only. For example, we have been learning about throughout these days that 8051. And after 8051, what? Basically 8051 also came into existence because of the need only, because they felt that something is short in the microprocessors, and therefore they added few things and microcontroller came into picture. But now within microcontroller there are variety of microcontrollers. How about that? And now especially looking at my slide, which states that there are different advanced versions of the microcontroller that can fit go right and that can fit into your real world industrial application. So for example, Atmel. So you can see that there are controllers available from the Atmel, and why do you think that, and what do you think that it differs in the Atmel? So it takes me back, it reminds me of the story that when we started working with the controllers in 2000. So we were using 8051, having inbuilt 128 and 4K of memory, and we still remember we were doing all that external memory interfacing, and we were sacrificing those P0 and P2 ports, and the memories were like 277C512 having 64K of ROM, and since memories were very costly, we were not able to afford too many number of pieces of these memories. So the development cycle involved like using these external RAM or ROMs and programming them. And there used to be a complete application board wherein we used to plug in these modules, remove these modules, again program them, make the corrections, addition, subtraction, etc., edit them, and again check in the application whether they are working as desired or not. So it was that cumbersome and lengthy process, and removing that was like quite laborious. And another factor was like each IC used to take 30 minutes for erasing. So those ROMs 270-512 or 270-256, those were actually having those kind of windows at the top of it, and if you expose those windows to the UV rays, you are erasing them. So through UV light we used to erase them, and for completely erasing them it used to take us 30 minutes. So what a loss of time it was, and therefore the whole development cycle productivity was not that great. And it was but that is how it was at that time. And you cannot afford to have more than 2 or 3 or 4 memories also, as a result, because they were costly also, and it was consuming a lot of time. It was wasting our time, laborious, and development, and the bottom line was like at the end of the day we were not able to produce the results or product developments within the stipulated time period, in a very tight time schedules. It was like wasting a lot of time. So very intelligently and wisely, I think probably Atmel people thought about it, that developers are actually suffering this kind of thing. So what can be done about it? So therefore they came up with a new thing. And as I was saying, that these all developments have something linked with the advancements in the memory. So therefore that was the lacuna, that memories used to take a lot of time of erasing, etc. So Atmel came up with a new thing, and that thing was like electrically erasable. So they came up with the 889051 series, having a 4 kilobyte of ROM inside it. So therefore that what was special about this was like 80 stands for Atmel, 89 stands for electrically erasable flash memories. They call it flash memory, and this is a worldwide known standard and industry standard. That wherever you find 89, that means it is for flash memory. So these were consisting of the flash. So a controller having a flash memory inside it stands for 89, and so 89C is the CMOS, and 5 means 4K of ROM. So Atmel came up with this approach, that the electrically erasable. So now the developers were like were relieved from all that trauma or all those efforts, that removing the IC and erasing it for 30 minutes. So that is how Atmel came into existence. And they had then so many versions also available. So now for developing of any industrial applications, you can go for either 4K ROM or 8K ROM. 5.1 is 4K, 5.2 is 8K, 5.5 is again 32K. Then WD version is there. So there are a lot of versions available in Atmel. Same goes true with any other manufacturers that are listed here. For example, Philips. Philips, there is again story with the Philips, that okay, fine, Atmel took care of that erasing and all that. People were happy about it. They were removing it or programming it, and they were getting it again reprogrammed in a fraction of seconds, because flash memory means fraction of seconds. It erases and programs. So they were removing, again putting it in the EPROM, this programmer, and doing all that. But then Atmel thought that because unless now this, and moreover in this case what was happening, like it was a programmer, you have to purchase the programmer, so many hassles were still there, and what we want and expect is actually hassle-free life. And so Philips came up with another thing, and the need was like, can we program this kind of your systems without removing the chips, and something called as in-system programming, like keeping the things intact, you are not removing the chips, etc. And these are all the groceries of the embedded system world. This is called as in-system programming, the new thing they came up with. And without removing your chips, now one can program the whole system. You just make the changes in your IDE and get it downloaded, burnt. Okay, you are burning it inside it, and again check the performance, just change the code like that. So you are not removing the chips, because in removal, wastage of time, as well as sometimes it was like a case that you may break its legs or those pins. So that was the scenario. So Philips came up with another invention or innovation, because that was the need of the hour, and it again brought up and scaled up the productivity of the embedded system developers. And besides that, Philips also gave a concept of in-application programming. So without, one was in-system programming and second was in-application programming. So what is this in-application programming all about? One thing is, like, you might be noticing that, okay, now once your product is developed, now it is deployed in the application. Now what next? Sometimes it happens that, let's say, take an example of your mobiles or so, and there are many products in the real world that they are just deployed, and then what happens is that they need to have continuous updates, and you're updating the systems, and then that is taking care of the things, like your DTH at home. Then they completely change its hardware and the code inside it, or many times in your mobiles also there is a system update available. So they fix the bugs, they improve the performances, they add some new features to it. So there are a lot of embedded system products which are available, and these days the whole world has become the connected, LAN connected, and worldwide, anytime, anywhere, any device, Internet of the Things. So your washing machines can be controlled remotely, your all the household things can be controlled remotely, your cars can be controlled remotely. What does that mean? That you can remotely control the things, and these things are possible only through the in-application programming kind of concepts. So what this in-application kind of concept does is, actually, without stopping your, many times it happens that you don't want to stop your applications, but you want to make those changes happen in your system, take them into effect, and again keep running. So without actually removing the system from the service, from wherever it has been deployed. So in application programming, when the system is in application, it is working, still you can bring the changes remotely, and your systems can still keep working. So without making any breakdown or disruption in the services, this all is possible. So Philips gave this kind of concept. Same is the story with many other controllers like Silicon Labs. Because you see, we are talking about all industrial applications which are real world in nature. And what happens, real world is actually, it has different requirements. So one of few requirements have been taken care by Philips and Atmel. Now Silicon Labs also, it has its own story. They also launched a controller, and they all have the 8-bit controllers, okay, what we are talking about. Now Silicon Labs thought about something, and again they felt a need that real world is all real. Real world is all real, and real world is actually analog in nature. The real world is analog in nature, and what we talk in controllers normally is digital in nature. So they thought, now what is required is actually having some kind of core mixed signal cores, having all an analog and digital together placed on a single chip. So system on a chip having analog and digital all together working to serve the purpose and serve the application, any industrial application. So Silicon Labs came up with a very good, nice architecture, C8051F120, 020. There is a lot of family, whole lot of family to it. 100 pins, 60 pins, 40 pins, 20 pins. So different configurations are available. 100 MIPS speed, different memory configuration, 128K, 64K, all different kind of, whole lot of varieties available in Silicon Labs. And they also have very unique kind of architecture which uses the crossbars. In crossbars, what they did was they brought in so much of functionality into that chip, because it's a mixed signal chip, which is the need of the industrial applications. So there are a lot of features like programmable gain amplifiers, or analog DACs, ADCs, programmable counter arrays, timers, counters, etc., etc. But then, despite adding so many analog digital peripherals, you cannot allow your core size and pin count to increase to to a higher level, let's say more than 100 pins or 200 pins or so. So what they did was they are still keeping the pin count same, and they are actually mapping the different pins to different functionalities. So they have done it successfully through a kind of arrangement, kind of scheme called as crossbars. They call it crossbars. So what these crossbars they do, they allow you a functionality, programmability to the user, wherein you can program different input-output digital peripherals or analog peripherals, and you can program them, hook up them, or tag them to a particular pins of the controller. And same pin can act as a communication interface, same pin can act as ADC, DAC, all the multi-functionalities on a simple single pin, and their programmability is there. So that is what these Silicon Chip Labs have done. Then there is a PIC also, PIC Advanced Controllers. which can be one of the requirement of your industrial applications, because your application will govern the selection of the controller that you intend to deploy there. So PIC controller is another one of the reliable controller, because there is again need, as I went on saying, that every controller, every manufacturer actually came into existence with a kind of need, real world need. So same way PIC wala mein ye hai ki they thought, in what happens is you want reliability. You want very good reliability in real world applications. Industrial applications, what is special about industrial things? Can you tell somebody? MIT? What is so special about the industrial atmospheres, industrial ambience, work ambience, or what kind of ambience is there in case of industrial applications? Yes, I have got some. Yes, please go ahead.
I am from NIT Greater Noida.
Yes, please go ahead.
I feel the industrial environment is a bit harsh.
Peculiar about the industrial applications and what kind of ambience they have and all this.
So in industry we have a high temperature, high pressure kind of environment. So our controller should be robust in those conditions.
Exactly. Thank you very much for that. Thank you very much for all that nice answers. Here also in the classroom, I am getting very good answers. Basically, the environment is very harsh. Yeah, you are again okay. Yeah, please tell. Please go ahead.
There is a doubt that is the flash memory same as the EEPROM, or they are different?
They are same. Basically, flash is electrically visible, and advancements in the memory, like as we say that there are normal memories and electrically visible memories, and flash they are almost same basically, because with the just pulse of the electric pulse, they get erased. They can be considered. There is a slight this demarcation people identify it, but they are as good as same because they are electrically erasable. Flash is actually just with the impulse. With the impulse, they get erased. So it is electrical impulse only. They are same. They can be categorized. Books also they have categorized it into the same category: flash and electrically erasable.
Okay. Thank you.
Yeah, thank you. So okay. So yeah. So what is special about the industrial thing is the environment is harsh. The environment is harsh, and therefore normally they have a lot of noise and etc. And controllers they are prone to this kind of they need to be prone. They are prone to have kind of some crosstalk or erroneous function. So there are chances that they may not perform, they malfunction. So therefore it should have a kind of immunity, inbuilt immunity. They should be rugged in nature. Reliability should be high. That is what is expected as far as the industrial applications and industrial environment is concerned. So that is what is actually taken care in the PIC. PIC is considered as one of the most robust controller in the family, and let me tell you, it is the one of the leading and #1 manufacturing company from microchip as far as the 8-bit microcontrollers are concerned. And this is only because of the reason that they have brought in a lot of new concepts like pipelining architecture, RISC architecture, hybrid architectures, and hardware architecture, wherein you have separate address and data buses connected to these cores. And at the same time, like they have also brought in new concept like proper power on, proper oscillator stability through kind of timers. So power on oscillator, power on timers, oscillator timers. There are few watchdog timers. There are number of few timers available in case of PIC controllers from microchip family, which provides the extra reliability and ruggedness. For example, because you want to have your application very reliably working in the real world. For example, in controllers, unless you ensure that the power it reach the proper levels, you cannot, that controller will not properly function. There are chances that it may malfunction. So therefore, there is a specific power on timer is there inside the PIC, which ensures that in a defined and required time period, it is attaining its required voltage levels. So that is how it ensures that power is the chip is properly powered up And secondly, it also, these are the important things, as I was discussing the other day, that in the most basic configuration that a controller should be receiving its proper power, and it should be receiving proper oscillations at 18, 19 pin number crystals. So therefore, these are the two things which PIC controller ensures. Its architecture ensures the power on timers. It ensures that the power reach to its appropriate level in a given period of time, because in industrial atmosphere being a harsh, there are always chances that the power supplies are not that reliable, or some noises are there. So therefore, that is to take care of these issues. There is inbuilt timers available in PIC. Similarly, the oscillators should be attaining proper oscillations or the required levels. So there is a power on oscillator. So there is a oscillator timer check. So there is another timer which ensures that within a given period of time that oscillators have reached and they have stabilized. Because unless there is stable oscillations available to the core, it cannot work nicely. Then another thing is, like, if your application is working at a remote end, for example, somebody is sending Land Rover to the moon or Mars, that kind of missions. So these robotics applications, it should be working reliably. And if something goes wrong with your code or so, what happens is that it goes into infinite kind of loop or some kind of operations wherein it needs to come out from there. So there is a watchdog kind of timer kind of thing, which there is an internal one clock is there in this watchdog timer. When you switch it on, yes.
One more point to be added is in the you can say space-based system or like that. That is fault-tolerant system. When you are going to design fault-tolerant system, there at that time the processor should be highly reliable. When you need two microcontroller, two microprocessor, two support system working in parallel to each other on the same data and the same output is to be generated in a synchronized manner.
Yes. So distributed intelligence system can be.
Is a very, very important point over here.
That's true. And
thank you very much.
Thank you. Thanks for that input, and I hope audience is getting benefited with all those inputs. And therefore, besides all these things, there is a watchdog timer ensures, we were talking about watchdog timer, that if something goes wrong, because it automatically resets. Okay, if something is not coming out of the loop or something got into infinite thing, so this automatically resets and sets the system to the reset mode. So that is how, because in this kind of remote applications, and let's say we were talking about moon mission or Mars mission, once you send the vehicle or the spaceships or these Land Rovers or robots, you cannot go and repair them by going there. So these remote places need to have some kind of inbuilt systems which can take care of things. So this was one of the examples. It's not that the whole ships are, these vehicles are that protected or fault tolerant, or there are so many things. But PIC provide this kind of watchdog timer is one of the precautionary measure which helps to have this kind of reliable operations. So a lot of stories with all the advanced controllers, and they have different things. And what is embedded system by now must be clear to all of us, that it is a combination of software hardware meant for some particular application. So any industrial application, and this controller will be developed for that particular thing. There is an input like sensors, etc., and there is actuation, and there are inbuilt some algorithms. There are some rules which are stored into the processor, and controller plays a role of brain in the embedded system. Now here are some again interesting things, because whenever we develop any industrial application, we have to make some considerations, and one of the important consideration is actually selection of the right microcontroller, because thousands of controllers are available in the market, and which one to go for is a wise choice, and is an important choice to make. So we should be knowing, and I think there is some common sense to this, and there are some few technical aspects which we have to take into consideration. One of the important thing is that factors shaping the performance of microcontroller. Basically, when we go for the selection of the microcontroller, we expect that our system should work fast, because there should be a productivity, there should be a high throughput of any industrial application that you develop, because that is what they are meant for. Why are we replacing the man with the machine? Sometimes because of the reason that there are some odd places or something which cannot be handled by the human being, and the task is so tough or heavy or that kind of complicated, and may not be safe for the human being. So that is where we actually design the machines and ask the machines to take care of those things. So, and Uh, uh, so those are the cases, and so we expect basically when we develop these machines to have high throughput and high productivity. And for that, definitely if you don't select right controller chip, then it will not give a high performance to this kind of application. So first thing is that it should have good core and processor inside it, which gives the right thing like parallel processing and faster throughput, high MIPS, and etc. So what are the factors shaping the performance of microcontroller? Here are some details. That one of the factors is instruction set. You know, there are different type of instruction sets, RISC and CISC. And as we discussed that RISC is actually reduced instruction set computer, wherein you have simple and easy to execute instruction. Like PIC controller, most of its instructions are executable in one machine cycle and 1 byte code it takes, because finally it depends upon the how many machine cycles your instruction is taking and how many bytes it is consuming in the memory. So that is the total speed time it is taking for execution. So the instruction set in the RISC is actually simple and easy to execute, whereas in the CISC, this is what is CISC? Complex instruction set computers. So computers, they have the instructions are complex, like is actually using the single instruction to perform the operation instead of using number of instructions, which is the case with the RISC. So in case of number of instructions used are of RISC, the number of instructions used are more, but in case of CISC, although the instructions used are less per program, but these instructions take more number of machine cycles and more number of bytes are consumed. So in turn, it actually remains same, and sometimes this actually finds the outperform the things, because earlier it was like memories were not that advanced. So that also meant like going access time to the memory, and that was the philosophy of this. Like they said that okay, we'll develop and design the complex instruction set computer. The instructions are complex. They don't need to visit the memories over and over again because access time matters. So if they visit less number of times, that much time saving will be there. But but the whole burden was handled by the CPU. CPU was getting engaged because of those complications of the instruction. Whereas in case of RISC, although it might visit the memory more often because it is easy to execute instruction, so it is, and there are more number of instructions, so it is going, fetching, decoding, and executing. But then the instructions are very easy to execute, meaning that it takes one machine cycle and consumes less bytes. So therefore, it is easy. And these days, there are advancements in the memory, so they are fast also. It doesn't matter that how many number of times it is accessing the memory. So memories are relatively faster compared to the earlier philosophy, which was used in case of CISC. So therefore, instruction set what you are using matters. And these days, there is a mixed analogy or mixed approaches are being practiced. There is a mixture of both, and PIC kind of controllers uses the RISC kind of architecture. So therefore, what kind of core that you will select for your industrial application, it will matter that what kind of instruction set it uses. For example, in Intel's you are having that CISC architecture. So therefore, 111 instructions it is using. Whereas in case of PIC, it is a RISC. It uses only 35 instructions, and they're easy to execute instruction. So instruction set definitely matters. Then size of the CPU, which is I think easy to understand, that we know all very well. Like if it is 8-bit, then it is like one lane, and if it is a 16-bit, there are 2 lanes. So you can definitely, there is a more throughput and more productivity if more information is being processed, because the highway, that 8-lane or 2-lane, 4-lane, that kind of analogy is actually now able to perform more. It is able to process the information more information it is able to process. So there the size of the CPU matters, the word size, word length of the CPU, which is called 8-bit, 16-bit or 32-bit, and these days even 64-bit, 128-bit kind of things are there. And finally, actually the real performance varies application to application. It meaning that like if you select some controller for some application, let's say you are developing some remote, or you are developing some PID controller, okay, for the industrial application. there is some particular controller is selected for that, which needs some 10 IO pins or 1 ADC, 1 DAC, etc. Whereas there is another complete greenhouse that you are developing, or some operation wherein there is a lot of complexity. Let's say smart village, smart city, or smart classroom. So some application wherein the complexity and the operations to be dealt with are more. So therefore, the one controller which is selected for one application definitely will not perform as good as it is performing for that application in some other application. So application to application, definitely the performance varies. So you cannot go with the logic that this controller is working fine with this particular application, so it is good in performance, it has got very good speed, and this should also go nice with some other applications. So it depends upon the complexity of the application, and therefore this is one of the parameter which should be considered while which shape up the performance of the industrial application. Then, as I was telling you, that rough estimate is MIPS. That if you are not at all aware and you don't, in a layman's language, you don't want to scratch your head too much, then you can simply go for MIPS. MIPS is one of the important measure of the controller speed. So if that is but although it is a rough estimate, there is a they call dry stone also. Rough estimate is actually MIPS. Although it is a not very fair estimate, but it is a rough estimate, but it gives you some sound idea. And most of the manufacturers, it is one of the important parameter which is stated in their data sheet. Whenever you select any controller, they will definitely mention that what is the MIPS, that is million instruction per second, how fast it is, an engine, like how fast the instruction. Okay. And if you want to have really true picture of the performance of your controller, then the best practice is actually there are some standard routines designed. So the routines which are designed to test the processor. So if you use them, like okay, this particular routine, if it is burnt into a particular core and seen the performance, and then it is burnt into some other core and seen the performance, that is the true picture of knowing the real performance of a particular processor. So these are some factors shaping the performance of the controller. And then obviously it matters that how much power your controller is consuming, because these days everything is like power consumption. Whenever if you are buying mobile also, we just go and check that how much is the battery backup, because most of the things these days and as are expected to be operated. Okay, all those devices, gadgets that we are using these days, whether laptop, mobile, your palm top, tablets, your cameras, or anything else like that. So those are all battery operated, and therefore power consumption of the controller matters. Although the power that is being consumed by the controller is very, very less in microamperes, but still it is expected that it should have lesser power consumption. And the cost, I think, very obviously, and it goes with the common sense that we expect that the cost should be less, because the controller, let's say you are selected some controller of 50 rupees or 40 rupees cost, and one product is using that, and if that can be 40 rupees instead of using 50 rupees controller, there's a big difference. 10 rupees is a big difference, or 5 rupees is a big difference. Every penny counts, and therefore the selection of the controller should also take into consideration obviously the cost factor, which is very, very important. So therefore the very first idea is actually you should write down your specification of the industrial application that you want to develop, and then you go for the selection according to the specification, because then it will be clear to you what are my input specifications. Then tools availability. What is big deal about this? Tools availability is very, very important. It should not be in your whims and fancies. Okay, you're talking about this controller is like this, it has got this kind of powerful feature, that kind of powerful features, but then you find that the tools available, development tools, because there are so many development tools that we need: debugger, assembler, compiler, okay, burner, and so on. So tools availability, unless you have the tools available easily for that particular core, then I mean it is of no howsoever powerful that. So therefore, in my views, it would be the best case if my controller chip allows me to program everything from my controller easily. I don't have to buy anything. I don't want to invest any single rupee even for any development tools. So simply there is a chip and the laptop which is normally zero cost solution. That laptops are normally available with everyone, so you can have your own laptop. There is a chip, you just program it and it works. So that kind of scene is, and that therefore open platforms are more preferred now. Okay, like open tool platform wherein your compilers are freely available, you don't have to buy them. So those open platforms are more preferred, and therefore tools availability, because this all adds up to the cost of development. So tools availability is most critical. Reputation of the company. You see, whenever you develop something, it should not be like freedom 251 हो गया. Otherwise, you might be aware एक Ring Bell ने एक product launch किया था mobile का freedom 251, and they are no more in the market now. So reputation of the company will matter a lot. आज आपने कोई product develop कर लिया and you have used some controller in that product, और पता चला कल वो company bankrupt हो गई, पता exist ही नहीं कर रही है. So you have to go with the reputation of company कि उसका track record क्या है, 10 साल से 15 साल से कंपनी काम कर रही है, सक्सेसफुली लोग उसके बेस पे प्रोडक्ट बना रहे हैं, जैसे एटमेल है, फिलिप्स है, सिलिकॉन चिप्स है, जो मैं खुद 15 साल से खुद ही देख रहा हूँ इनको, टेक्सास है, एनालॉग डिवाइसेस है. तो दिस विल मैटर कि भाई रेपुटेशन ऑफ द कंपनी क्या है, एंड देयरफॉर दिस विल मैटर. अदरवाइज योर डेवलपमेंट विल सफर. अगर आपके वो डिलेज आ गए, इनकर हो गए कि आपने शुरू किस पे किया था, बीच में वो गायब हो गया, तो फिर आपका काम बीच में रह गया. और या फिर प्रोडक्ट भी डेवलप हो गया, मैं कहता हूँ चलो प्रोडक्ट भी डेवलप हो गया, बट देन यू फाउंड दैट अब उसकी चिप्स अवेलेबल नहीं है जी. नाउ द चिप्स आर नो मोर अवेलेबल बिकॉज कंपनी इज नो मोर एग्जिस्टिंग एंड सो ऑब्सोलीट. एंड सो देयरफॉर योर प्रोडक्ट डेवलपमेंट अगेन यू विल हैव टू डेवलप दैट प्रोडक्ट. सो रेपुटेशन ऑफ द कंपनी डेफिनेटली मैटर्स. एंड sorry, application, as I said, that application will matter. Now besides, as an embedded system design engineer, industrial application development, what will matter is कि आप जो develop कर रहे हो वो कितना efficient design है. And efficient design means it can be hardware wise, it can be software wise. Why do you think that Chinese people are able to develop that kind of products very cost effectively or so? Because a lot of innovations and efficient design engineering is required, and I think India is far more ahead, because the kind of nano car that India could produce, no one could produce so far at that cheaper rates. So Tata made that kind of car within 1 lakh rupees. So we have got a good track record as far as the cost effectiveness is concerned, and there were I think 25 or 50 patents filed on that kind of products. So engineering wise, India is also not lesser than anyone else. So therefore it will be worth watching and worth understanding what are the efficient design consideration. And sorry, when we talk of that, again it comes to hardware and software. Now from hardware perspective, what is the first efficient design consideration includes fewest voltages. What does that mean? Fewest voltages means ideally your whole product, industrial product, should be working on a 1 voltage ideally. Okay, 5 वोल्ट पे है तो 5 वोल्ट पे काम कर रहा है, 3 वोल्ट पे है तो 3 वोल्ट पे काम कर रहा है. मार्केट से देखो, आप प्रोडक्ट लेते हो, एक मोबाइल खरीदा, ये है क्या कि वो कहते हैं कि आप ऐसा चार्जर लाओ जी कि उसका आउटपुट जो है 5 वोल्ट भी होना चाहिए, 3 वोल्ट भी होना चाहिए, उसको 12 वोल्ट भी चाहिए क्योंकि ऑप एम्प लगा हुआ है अंदर, वो +12 -12 वोल्ट लेता है, और जो हमारा कंट्रोलर है वो 3.3 वोल्ट लेता है. ऐसा नहीं होता ना. सो दैट इज व्हाट इज एक्सपेक्टेड कि हार्डवेयर जो आपका फ्यूएस्ट वोल्टेज और आइडियली 1 वोल्टेज पे चलना चाहिए. सो आपका एडीसी है, डीएसी है, कंट्रोलर है, एलसीडी है, कीपैड है, जीपीएस है, जितने भी एम्बेडेड सिस्टम के आपके इंडस्ट्रियल एप्लीकेशन के जो आईओ पेरिफेरल्स है, ब्लॉक्स है, दे शुड बी वर्किंग ऑन दी fewest voltages. Okay, ideally 1 voltages. And these days almost everything is available on low voltage versions like 3.3 volt, etc. And that can be used. Then next hardware consideration, efficient design consideration, includes conserve power by smart choices. Obviously you have to use the smart choices and you have to conserve the power. For example, आपने देखा होगा मोबाइल में your LED backlight automatically goes off. ठीक है, so it will conserve the power. There are a lot of software settings by which it consumes the less power. So smart choices. So you can have smart choices. Then backlight हो गया. then it also happens many instrumentations or many technologies or many industrial कुछ application ऐसे है कि when you are not using them they automatically shut down. For example classroom से कोई वहाँ पर है नहीं कुछ नहीं है तो automatically सब चीज ऑफ हो जाएगा स्मार्ट क्लासरूम. कहीं पर ऐसे भी है कि आपका एलिवेटर कोई यूज नहीं कर रहा वो बंद हो जाएगा. Okay, so something like that. So shutdown when not in use. So that is called as, these are the efficient design considerations. So while you design your industrial applications, you have to bring in this kind of novel concepts wherein there is all these factors. Availability. Why, as I said, ki hardware ki availability is most important aspect. And temperature stability and calibration. Ki many times, many things, there is always a temperature drift. With temperature almost everything changes. There is always drift कि जो चीज there is a drift उसके परफॉर्मेंस में चेंजेस आ जाते हैं तो आपके कैलिब्रेशन इनबिल्ट होने चाहिए कि they are actually taking care of this kind of drifts and errors. So temperature stability and calibration, that should be the hardware consideration. Otherwise you are developing it for something industrial application and then they change and then the performance is no more there and you are not getting the desired results. Next point is develop to the eventual form. What is this develop to the eventual form? Any idea? So develop to the eventual form is nothing but आपको अगर कोई प्रोडक्ट बनाना है ठीक है और मुझे प्रोडक्ट बनाना है ऑफ द साइज ऑफ दिस मोबाइल और ऑफ द साइज ऑफ दिस मोबाइल और एनी मे बी रिमोट कंट्रोल ऑफ दैट साइज और ऑटोमेशन है मुझे पूरा एम्बेड सिस्टम बनाना है मुझे माइक्रो कंप्यूटर लगाना है और मैंने क्या कर दिया उसकी फंक्शनैलिटी पूरी अचीव करने के लिए कंप्यूटर पे डेवलपमेंट शुरू कर दिया. ठीक है, अब कंप्यूटर देखिए कंप्यूटर डेस्कटॉप पे मैंने डेवलपमेंट शुरू कर दिया. इज इट पॉसिबल कि मैं उतना बड़ा प्रोसेसर को लेके मोबाइल जैसा कुछ बनाऊं या माइक्रोवेव या वॉशिंग मशीन का मैंने चीज बनाना था कंट्रोलर बनाना था एंड आई हैव स्टार्टेड विद समथिंग लाइक अ डेस्कटॉप काइंड ऑफ थिंग सिनेरियो. सो मीनिंग एंड फाइनली मैंने कहा ओके इसमें फंक्शनैलिटी अच्छी होगी अब मैं इसको रिड्यूस फॉर्म करूंगा आई विल कॉम्पैक्ट द फॉर्म एंड टेक इट टू द कंट्रोलर. सो इट इज अ वेस्टेज ऑफ टाइम. आप पहले उस पर डेवलप करो फिर उस पर डेवलप करो. दैट इज व्हाट इट मींस कि आपको जिस फॉर्म का चीज प्रोडक्ट बनाना है इंडस्ट्रियल एप्लीकेशन डेवलप करना है उसी फॉर्म में आप डायरेक्टली डेवलपमेंट करिए. ये नहीं कि शुरू कहीं से किया था और वो कुछ और रहा है और रिक्वायर्ड कुछ और है. सो develop to the eventual form. Then fuse boards. What kind of mobiles in mobiles there how many boards are there? There is a single board. मोबाइल के अंदर सिंगल बोर्ड होता है ठीक है और योर कंप्यूटर के अंदर देयर इज सिंगल बोर्ड योर लैपटॉप के अंदर देयर इज सिंगल बोर्ड पीसीबी. सो व्हाई डू दे डू लाइक दैट? बिकॉज सिंगल बोर्ड में जो है आपको रिलायबिलिटी अच्छी आती है एंड देयर इज अ गुड रिलायबिलिटी नो लेस फेलियर्स and system is rugged, compact and all this. Cost is reduced. If there are more number of boards, cost is increased and compactness is not there. So cost effectiveness is not there. Power effectiveness is not there. Space effectiveness is not there. So it is not serving the purpose. So it is preferred that fewest boards, number of boards lagane hain as far as possible. Similarly, there are software considerations कि जिसमें easy to understand code लिखना है. Function से आप develop functions use करो सी के so that it is easy readability होनी चाहिए and there is reason for everything. Why it is so? There is reason for everything because team में काम होता है knowledge transfer हो गया कोई छोड़ के चला गया टीम डिस्टर्ब हो गई then this all matters. टेबल्स और कैलकुलेशन अगर आप टेबल लोगे तो कंट्रोलर जो है ज्यादा बिजी नहीं रहेगा कैलकुलेशंस के लिए. सो टेबल जो है लुकअप टेबल्स आप यूज करने चाहिए. रियल टाइम इंटरप्ट्स यूज करने चाहिए. सो इट इज मोस्ट एफिशिएंट बिकॉज हार्डवेयर ड्रिवन चीज है. सो वेक्टर पोलिंग नहीं करनी है आपको रियल टाइम बेस करो और मल्टीटास्किंग करिए. ओके now in any kind of industrial application you would come across this kind of some IO peripheral interfacing task which includes LCD, keyboard, motor, GUI, RTC, square prom, GPS, LEDs, any sensor, GSM, and list goes on. There are so many peripherals that you can interface in the industrial applications. Now we will see some examples that we worked upon in our labs. So one of the application that we can see is actually water contaminants watchdog pod. In real world, as we say that anything that we are doing or learning or this embedded system, the purpose is, as you can see on my slide, the purpose is actually to serve something. Okay, and one of the best application can be like securing the water for the country. And they say that I'm going to tell you this one of the application of the microcontrollers, how different kind of technologies can be made and how can you make a difference and how can we serve, because we all have role to play. And they say that if at all there is going to be a future war, it's going to be on the water. And I mean, there is logic to it, and you'll agree with me as soon as I will show you some statistics or so. It is quite possible that this all is possible, and therefore how do we ensure the water security for the country? And that is the prime most concern for most of the countries, because there are few securities like water security, food security, and energy security. These are the most important securities for any country or an individual is concerned. Water, and as far as the water is concerned, it is central to the well-being of people and planet. So we must work together to protect this fragile and finite source, because it is not something that which is available. It is very fragile. Okay, it is scarce, and it should be protected. Now, these are the important securities that we all need. And you can see in this cartoon, which says that हमारा तो रोज ही जो है IPL होता है. IPL is not Indian Premier League but Indian पानी लीग, और हमें उनको जो है 20-20 किलोमीटर से दूर से जो है पानी लाना पड़ता है. And the situation is becoming very worst in our country. Almost 1 billion people are going to be under water scarcity out of 4 billion worldwide. So water is a big issue, and you know what is happening. I have got some pictures also to show you on that, what is happening across the country, what is happening in Latur. Okay, and people are migrating on the issue of water. A lot of things are happening. So from the entertainment like IPL to the actual real world, water is so much important, and therefore it needs great attention, and industrial application should be developed to protect the water, to reduce the use, to recycle, to reuse, etc. And microcontroller can definitely play a big role, because it can automate and it can provide all that intelligence everywhere in the water management. People will be able to know the things on mobiles. People will be able to manage the things if we can, and all this automation can be possible by using the controllers and by embedding some machine intelligence into it. And there are some scientific studies on weather forecasting and water stress. As you can see in this picture, that heat wave is going on across, and each month passing, each day passing, actually a lot of heat is increasing, temperature is increasing across the world, and India is at the center of it. And that is what is shown. These are some forecastings done by the United States Department, Forecasting Department. One of the picture you can see here, which depicts that water stress around the world. And this is the statistics by the World Resource Institute. And you can see that India is again at the center and is leading. Here actually somewhere the India is there, and with the dark colors red and yellow, which depicts that high. Okay, it says that extremely high and high zone where the India is lying, wherein the water stress is going to be faced very high. Okay, and that is what the recent studies by the World Research Institute says. And these are again some studies by some researchers, and the article has been published in Nature, which says that a lot of these shifts in spatial patterns of relative human water security threat after accounting for water technology benefits. So water security threats are observed as highest. Again, you can see here red and yellow colors where this arrow is pointed. These water spatial patterns and threats, water security threats, are highest in our country, India, compared to the worldwide predictions. And all these actually have been this incident of human water security threat is highest in our country compared to all others, and there is a lot of biodiversity threat as well. And on the other hand, India is actually top global water consumer. It's number one, followed by China. 30% of water is being consumed by our country, and we are the top 7. We are among number one among the top 7 global water consumers. And now see, on one hand there is a great water security threat, and on the other hand we are a top global water consumer. So how do we balance and how do we meet these requirements? And you can see in one of the clipping here that, as I said, globally 4 billion people will suffer from water scarcity, and India there will be 1 billion people who will be suffering from the water scarcity. So therefore I think it is a great problem of concern for developing the microcontroller based applications. And in one of the, again, the statistics, you can see that India's water security index is very, very poor across worldwide, and a lot of contaminated areas are there, like Rajasthan, Bihar, Bengal and Maharashtra. They have been contaminated with severely, very badly with these water contaminants, and therefore making this, leaving this water not usable. So this is very, very relevant and important in the industrial applications. And recently also there are different items in daily news which you might have seen, and some clippings are given here that India has the most people without clean water as per the report. And you can see very innovative solutions that are coming to tackle the water crisis. Trains are arriving. Excuse me. Hello. Hello. हाँ जी, हाँ जी. So water trains arriving and fulfilling the requirements very innovatively, and you can see that unemployment and what are a lot of this crisis, and people are migrating because of these issues. And water pumps, they are giving the toxic water. Now how can we tackle with this? So there is a lot of research going on at CSIO, and some technologies are being developed at CSIO. And what is the ongoing research and development in water? That's what I'm going to just give you glimpses about. And these are some prior art. There are 2 projects that are going at our organization, research projects on water, wherein we intend to develop some real-time water quality monitoring watchdog pods, which is the embedded system connected with the GPS, etc. And that will remotely transmit all this water information for arsenic, fluoride and nitrate. And we did a lot of research and published it in some good journals. And this is the kind of technology that we are developing at present at CSIO, wherein there is this P-tongue, I-tongue kind of scenario wherein software sensors are being used, and then this is being actually whole programmed into the microcontroller, and those logics and knowledge development actually uses pattern recognition, some kind of intelligent soft computing techniques, machine learning techniques, through which all these features are extracted, and the water quality is being monitored and is known, the information is known, and they can be like wirelessly transmitted to some remote regulatory bodies, etc. For example, what is happening, what has happened to all natural things in our country you are aware of, because the tendency of human being is whatever is available free of cost, we don't care. Okay, we don't care. And what has happened to ozone layer that we damaged, soil we deteriorated, water we deteriorated, air we polluted. What is happening in the Delhi? Okay, you are all aware of that odd even formulas. So basically, whatever is coming free, we are not bothering, and if it is our own house, we are very sensitive about everything. If what this fan is on, electricity is on, we'll switch it off or so. And so because it is built, because we have to pay for it. So therefore we thought of like kind of concept, all the rivers are being polluted by these industry people, industrial units, and what happens is that by the time pollution control people will reaches there, they start their effluent treatment plants and show that they are monitoring the things and doing the things nicely. So therefore we thought, why not to develop a technology which can 24/7 365 days can monitor the industrial units and will not allow them to pollute, isn't it? So it is like, 24, there is a GPS which is connected to that technology, so geographical location of that particular industrial unit is known to you, and just by sitting at the Delhi, your pollution controlling authorities or PCBs or these central groundwater controlling bodies, so all these authorities by sitting at Delhi, they'll be having the all this monitoring possible just next to their desktop, and because this will be wirelessly transmitted through Internet of the Things or cloud, etc., and you can monitor the and then if some industries are polluting or they are crossing the thresholds, then they can be billed accordingly. If they have crossed some threshold, okay, this threshold is crossed, now they have to be billed accordingly. And because there is a 24/7, it is a human interference free, 24/7 GPS is attached, so all is like that. And this can take care of all corruption also. I mean, normally by the time pollution control people go reaches, and then there is a lot of tampering happening, and then everything goes on like that. And I think these kind of technological solutions can take care of these aspects, and they can monitor. Here you can see that there is a discharge source, so this is the inlet and there is outlet. In between that there is all these embedded systems and controllers which is taking care of it, and this kind of things are actually going on at CSIO at present. And then next is and the long-term vision is something like this. We want to develop a real-time water quality monitoring watchdog pod, which can actually monitor our rivers, like Ganga river monitoring. You know what has happened to Ganga? It's polluted a lot, and so we need to have kind of different technologies to monitor these rivers and on a real-time basis, on a continuous basis. And we thought of developing this kind of sensor fusion node, and this sensor fusion node will this sensor fusion node will actually get the information about all the parameters, and then it can be processed and transmitted to a central measuring node, and this can be further transmitted using these different technologies, transmitter like Zigbee, 3G, 4G, or Li-Fi technologies. And then at remote end there will be again here this goes and received remotely, and this control node microcontroller board will actually put it on the web, so kind of Internet of the Things, wherein anytime, anywhere, any devices, all these information can be made available to the controlling bodies or some people like that. I mean, on the industrial units, it can be like remotely monitoring. On household, for the household people, it can be like on mobiles. They will be able to monitor the quality of their water tanks, whatever kind of water they are receiving. Is it of good quality or not? Is it of required quality or not? So total water quality index they will be knowing. So household level, industrial levels, at different levels, water management can happen, and through that we can actually, and then we can ensure the complete water security through these kind of measures. At present what is happening is, like, when you buy the water bottles in buses or railway stations, you simply rely upon their brands that okay, they are giving good water. Even at your household, you have just installed some water filtering units, and then you think that okay, that whatever it is giving correct, or you are just simply relying upon the brands, but you don't have any real world true picture or real time monitoring kind of scene wherein you can ensure that water quality is actually up to the mark, or it is free from nitrate, fluoride, arsenic, heavy metal ions, and so on. So therefore unless we have this kind of technologies, you cannot control the quality of the water. And even if you want to have remedial solutions wherein the water can be purified or filtered out and that can be made usable for drinking, so you need to also cross check it that whether it is done it or not done it. And well, these are some technical aspects wherein it shows that how we are doing it. There is some like there are some technologies like um, for monitoring the heavy metal ions, like such as arsenic. We have this kind of some method which is called as anodic stripping voltammetry, wherein particular signals are given for deposition potential, deposition time, and then there is stripping pulse. Then accordingly it senses and it gives a current proportional to the heavy metal ions. So that is what is shown in the top side. And then bottom you can see that there are optical techniques, fluoride and nitrate. So we have used some absorber based, UV based techniques wherein the UV source light falls on a sample and the samples absorbs the light, and corresponding to its concentration, you can get to know what is the level of the that nitrate present in the water. And in case of fluoride also, we develop some carbon dots, and it has a fluorescence characteristics, and depending upon the amount of the fluoride available, these carbon dots actually the fluorescence is emitted, and that gives the kind of quenching effect. The quenched carbon dots, they have different kind of fluorescence, and that fluorescence effect is actually measured through some different photodetectors, photodiodes, and they are finally calibrated, and the ADC reads of the microcontroller all these signals, it processes further and calibrates and displays it on the human machine interface. So presently, a lot of lab scale knowledge protocols we developed. These technologies, industrial embedded system applications that we develop actually cost just 10-20,000 rupees, whereas your imported systems, they are costing 50 lakhs, 25 lakhs, or 1 crore, even crores of rupees. So therefore, these systems which are specific, dedicated, because since they are dedicated to particular application, then only we are calling it as embedded system, and they cost very less and very cost effective, very compact. And you can see these are the technologies that are developed. These are the prototypes which uses there is this LED source and detector, and there is small compact board inside it which uses the microcontroller. So this is for fluoride. Then we have for nitrate, which is also again the compact version, and it is for the arsenic. So these are the technologies that are presently developed at our organization. So fluoride, there is a source, detector, and there is small PCB here, and we are logging the data. And these are different studies that we carried out for the various sensitivities of the sensor, water quality sensors and systems. And this is one of the studies that we carried out for the technology development at one of the lab scale trials in one of the National Environmental Engineering Research Lab at Nagpur. And these are the performance evaluation studies that we carried out, calibration and validation, and nitrate is here set up, and these are different calibration graphs which shows that absorbance versus wavelength, and the R square value is very high, more than 0.9, and therefore it is a very good result for this technology. And all this is being controlled by is being planned to be integrated, and there is small compact PCBs that are being made for controllers. We have not fully finalized, but we are exploring with PIC and Arduino this kind of different controllers, and there is one Silicon Labs also, because these are mixed signal things. And one of the thing is this arsenic that we are using some 3 electrode specifications for this. There is a working electrode, reference electrode, counter electrode, and they are actually this is the measurement protocol, and these are the PCBs that you are seeing presently. PIC controller 32-bit is being used for just development purposes, and we are just seeing all the performances and these testings with the arsenic with these PCBs that you can see. This is the sensing cell from where the signal is being measured, and this is the potential set circuit which is all interface with the PIC controller. And this is the block diagram which shows that 16-bit DAC is used, 16-bit ADC, then there is a filter, there are switches, SPI interface is there, and there are some VC counter voltages, referencing voltages, working voltages which are being fed by these potentiostat which are being generated by DAC, and ADC is measuring them. And this is where the electrodes and all this measurement setup is connected. Then there is a battery. This whole system is actually battery operated, and there is one motor required, vibration motor, which is to be interfaced. And this is all the schematic looks like. So this is the embed system that. And finally, it is expected that it will look like something like this. There will be a mobile, and all this technology will be fitted inside the box, and with some switching and controlling these switches, it will be able to connect to the mobile, and through this it can go, and there will be a IoT also, like through different 2G, 3G or 4G. It will be able to transfer it or transfer the data to any device, anytime and anywhere. And this is the again block diagram. This is some analog portion of it, and we can have different electrodes connectivity. We can have, like you might have seen those glucose meters, small strips wherein we can just drop and just measure it. So those kind of small compact micro systems are planned to be developed. So these are again these pictures, and how they are performing. As I said, they are performing 0.9, so it is a very good performance. And this is another sensor which uses the impedance spectroscopy, wherein for monitoring the water, river monitoring, this can be used, and it can at a time sweep and simultaneously can map different 8 to 10 heavy metal ions, different attributes using the impedance characteristics. This is the hardware block diagram of the same, wherein this automatic balancing bridge is being used, and there is the IDC card, microcontroller. Again, we are using Arduino, this big controller only, and Arduino also. And this is direct detail synthesizer, which feeds. This is a kind of programmable waveform generator, and which feeds the signal, AC signals, to this circuit, so that we can measure the impedances. Excuse me. Can you call the madam? So you have another connection? Okay. Excuse me. So this is what we have developed, and this uses the ABB, automatic balancing bridge, and some impedance circuits. So it maps, and this particular arrangement is used. And this actually we configured, and we have seen that particular impedances at what frequencies we should be measuring, and we found that at a 100 kilohertz we will be able to nicely characterize the water characteristics and water quality parameter measurement. And therefore further we actually developed this concept using this auto balancing bridge and magnitude ratio and phase difference detection method, wherein basically in this ABB method what happens is that basically you have to, for measuring the impedances, this is DUT, which is a I love to leave So in ABB, what is happening is that there is this, as I shown you, that there is DDS, direct detail synthesis programmable waveform generator here, which is interfaced and controlled by the controller, and then we are supplying this VS to this DUT, which is device under test, which is our water sample, and we have also used this for food quality also. There are two applications, industrial applications, wherein we are using it. One for water quality and another for the food quality, food safety. So herein we are supplying this input VS voltage, and the current IX is flowing through this ZX, and the aim is to find out this ZX, because this is the load device under test of which the ZX is to be measured and which will be calibrated against the water quality. And so what we did is actually we have to we have connected one trans impedance stage here, and wherein the same current is again passed IR. So IX and IR are same because being in series, and this is one range selector resistor which is connected here. So basically to measure, because we can measure this Z is equal to R is equal to V by I. So V by IX, that is how we can do it. But for measuring this IX, we are in terms of, we have converted this into in terms of the voltage. So trans impedance stage is being used, which convert this I which is flowing through this R. So Ix into RR, that voltage drop is being measured, which is equal to this Vm. So by taking this into calculations, we'll be able to find out the Zx. So you can see that Vm is equal to IR into RR, okay, and which is also equal to, like, we can replace this IR into Ix. So Ix into RR, that is how it is, and we can finally this equation can be like Zx is equal to Vs by Ix. So if you replace this Ix by this Vm by RR, so it will be Vs by Vm into RR. So this third equation will come basically. The second is actually not appropriate. So from first directly we can come to third. And if the values of, now you can see that if the values of Vs by Vm, this ratio is known to us, we can calculate the, and multiplied by RR, we can calculate the Cx basically. And that can be used further for water quality measurements or food quality measurements. And this all is being done by the controllers only. Microcontrollers are actually doing all this job. And finally we use some phase detectors. So this Vs, this is now another IC which we interface with the microcontroller. And what happens in this IC is we give the Vs and Vm, these two voltages, this Vs and this Vm. So these are the input to this IC. And this gain and phase detector IC basically gives us the ratio, gain ratio, K is equal to Vs by Vm, and angle theta, which is a source and measure angle. So this is actually source reference, and this is the measurement signal which is going through the water sample. And by knowing this K and theta, we can actually calculate the Z. So these are the details of this IC, which is a gain and phase detector IC. And K and theta is known like that. The ratios are calculated, which is directly coming from that IC, gain phase detector IC. And Zx is equal to, therefore, will be RR range selector and multiplied by ratio K into theta. So this is how we can basically calculate. And this is the final measurement scheme, wherein there is a direct detail synthesis which is attached to the controller. There is the automatic balancing bridge plus DUT through which the sample, whether water or grain sample, is poured. And gain phase detector basically will give us the ratio of Vs by Vm. And through this, we can finally use the ADCs to, because gain phase detector actually gives us in terms of millivolts. So those millivolts are read by this ADC of my controller. So one of the version was we can transmit it to the laptop, or we can give it on the LCD. So excitation source is available like DDS and this filter and amplifier and attenuator. And DDS is nothing but basically this is a programmable waveform generator which is numerically controlled. And basically these all details are given in the data sheet. So I have copied from there only. So whenever you will actually interface any chips and develop any industrial applications, the relevant chips, ICs, they will have relevant data sheets available. You have to firstly understand the complete hardware and that chip, and then by understanding the control, data, and address signal, there are only three things you would be interested in knowing. Because in order to interface and connect to your controller, you either need data or control and address. So somewhere you will have SPI buses also. Through SPI buses, just two-line communication, you will be able to transmit your data very easily. So once you get fully acquainted with the hardware, you can do that. For example, DDS works on SPI interface, so you can simply connect it to that. So your 8051 is not, by the way, having any SPI interface. Gain phase detector. So this is what I said I have used, and different actually. This is the basic measurement mode of that chip. These are all underlying basically the theoretical details of it. And this is what the actual setup, which looks like this, which we use for the food quality parameter measurement. And this is about the now findings of the water quality. We have developed it successfully for variety of range and specifications: arsenic, fluoride, nitrate, and heavy metal ions. Then we have future programs also in our mind, that wherein we'll develop different high-end systems which will use this kind of just strips, and through strips they will be all interfaced with the controller. And these are like a kind of colorimetry applications, wherein your mobile and with the digital image processing, you can just scan the colors and you can get to know the quality of the water. So these are all possibilities and future programs that we are in future we want to actually combine the microfluidic devices and with the smartphone devices. So we call it mobile sensing based on based on microfluidics and smartphones. So they will be clubbed together. The marriage of these both will actually give us new technologies, futuristic technologies like this. We will have these mobiles and these special gadgets are attached to it, and they will be able to this microcontroller is inside it. They'll be able to display you the quality of the water or environmental parameters. Basically, this falls under the environmental applications. These are all futuristic basically research areas wherein all is under the, done by the mobile sensing based on the smartphones, etc. These are special arrangements and accessories which are designed. So with that, I think end up here, and I will hand over to Madam, and you are free to put your queries on that. If you have any queries on that. Yes.
Let us hear from our centers if they have any queries. Deepika, which is the first center? MIT? Any queries? Yes?
Hello. No, ma'am.
Okay.
Yeah. I hope you have understood and liked that industrial application which takes care of the water security for the country. And
basically your last one, that means on water very much interesting.
Which one?
Sir, the data you provided.
Oh, thank you so much, thank you. And that is the real data, and it is really matter of great concern.
Yes,
and
sir,
therefore
informative data था और इससे ये भी पता चला कि एक नया टॉपिक हो सकता है बच्चों को फाइंड कराने के लिए भी.
Yes, water management is a big thing, and mobile based काफी सारी embed applications बन रही है, and it's a big thing now कि ऐप बन के ये सब जो है water के ऊपर काम किया जाए, because these are the main important securities for any country, water, food and energy. तो इन तीनों चीजों के ऊपर काफी industrial applications और microcontroller based embedded system applications develop किए जा सकते हैं.
बिल्कुल sir. Thanks a lot for introducing this area.
Thank you for your patient listening.
Next move for next center. Which one is it, Deepika? Next center. MMU Mulana. Any queries? Okay.
Thank you.
NIT.
Hello, ma'am.
Yes, sir.
I would like to ask what are the subroutines for testing the microcontrollers?
Subroutines, there are like hardware-wise, I think I was yesterday informing that reset trace, crystal test, then memory checks. Memory check, there are subroutines given in the ILA, KNFJ ILA, and so these are the basic subroutines, and rest all subroutines basically. Now there are subroutines for the one thing is there are subroutines for the different peripherals. Another subroutines are for the performances which are available on the internet. So otherwise, rough estimate as far as the performance is concerned, the rough estimate is like, and subroutines is like, I think those are not, I mean, specific things, but they will just perform like some arithmetic logical operations, and they will get to know, okay, this control is performing like that. So there are specific routines which will tell you the performance of a controller. If there is nothing loaded, it is not now loaded into any application. So bare microcontroller with those kind of some simple calculations which are they're available on the internet also, arithmetic logical units which takes the core and how fast it can do that job. Like it is all about how many machine cycles, how many bytes it is consuming that was particular instructions. So that is what it checks actually. And if it is based on the CISC or RISC, so automatically based upon the type of instructions used, it will actually check the performance of the controller. So those subroutines, either you can write your own small program, or you can use some readily available routines on the internet. So those are not very, I think something very complicated or very rocket science. It is this small, some 4 or 5 steps routine which tells you, okay, if I'm doing some addition, subtraction, division here in this core, and if I do the same thing on the other core, how it performs.
Any other questions, sir? Any other questions?
One more question, ma'am.
Yes.
Yesterday I've seen one of the program in C for giving the command to watchdog timer in 8051 microcontroller.
Okay. Okay. Yeah, you finished the query or question, or you want? It is yet to be.
Yesterday actually we had a question that is there watchdog timer in 8051 or not?
No.
I have seen a program where they are sending a command of watchdog timer.
No. Actually, Intel's 8051 there is no watchdog timer available as such, but Philips 89C55WD, I think watchdog timer is available, and there are many probably the controllers which are compatible with the MCS51 standard. Okay, those are MCS51 standard compatible, and they have watchdog timer and they are available from different manufacturers, not from the Intel's one. The Intel's 8051 of course is not having any watchdog timer. It has got the timers T0 and T1 though, but not the watchdog timer.
Okay, sir. Okay. Thank you very much.
Thank you.
Thank you for your queries. Next center, Dronacharya Group, Noida.
Good evening, ma'am. Good evening, sir.
Good evening, ma'am.
Sir, thank you for excellent coverage on applications of microcontroller. I had a query on routines which are used to test the performance of microcontroller, and you have already answered it. So we have no more queries.
Thank you. And rest all, I think we can always keep in touch. My details are, I think, I displayed it in yesterday's or some other lecture. So you can always interact on that. So you are always welcome to interact on anything on embedded systems, even if you don't have queries right now, right away.
So other center, Gurgaon. Dronacharya Group of Institutions, Gurgaon.
Thank you, ma'am. Thank you, sir, for sharing such a nice information regarding the water crisis and the role of microcontroller there. Sir, I have a question. When we burn the microcontroller during our lab sessions, so what happens after maybe performing a few experiments, after 10 or 13 experiments, microcontrollers start stopping giving the response? Actually, it does not work. So what happens? It happens with the flash memory, or it happens with something with the kit, or something with the microcontroller?
Yeah, I think each controller is meant for number of cycles it can work for, those erasable cycles. How many number of times you can erase, but so there is always limit to it. But definitely it is not as small as like 10 or 15 times. It is 1,000 number of times or so, or 100 number of times or so. So one of the possibilities, I think we normally are buying something in the gray market, the controllers. So I think these are used controllers probably. Those controllers have been used already, and that we are buying something second-hand thing, and so they must have used it several number of times already, and therefore when you start using it for few number of times, it automatically it already lost its life. So one of the possibilities is that. And second possibility could be that something went wrong and its boot vector got corrupted, etc. So therefore maybe that its vector got corrupted and memory got corrupted, and therefore it stopped
Please
responding.
change the microcontroller. एक बार change करके देख लीजिए.
Obviously, I mean, if you change the controller, it will work. But I think what I understood was like same controller. What you were saying was if repeatedly programmed, then after some time it starts giving the problem. So most likely the controller must be faulty.
Okay, sir, but how many times the flash memory can be raised and written? Is there any duration or?
Yeah, there is a number of cycle, and now as I said कि thousands में होती है, हमारा तब तक काम हो जाता है normally. So I mean I cannot say it is unlimited, but there are in the data sheet it is given that 1,000 cycles it can be done. So there are cycles, number of cycles for which total how many number of times. So maybe 1,000 or 100 number of times you can go on doing so, because doing it over and over again and over and again, it will actually reach to its limits. As soon as it reaches its limit, which is given in the data sheets of a particular controller, it will stop working. So flash controllers are like that.
Okay, thank you, sir.
Thank you, ma'am. Thank you.
Okay. So thank you. I thank Dr. Bhavan Kumar for sparing his valuable time and giving us such an enriching lecture on the real-world applications of embedded systems on microcontrollers. And I hope all of you had a good time listening to his knowledge.
Yeah, and I would request madam to display my slide, because my contact details are mentioned over there.
And in case you
are
have any
welcome
queries,
to keep in touch, and I'll be happy to give you some assignments, research assignments, which makes use of controllers, and it will be good.
So if you are interested in working on real-time problems, or your students are interested in working on real-time problems, you can kindly note down the details of Dr. Bhavan Kumar.
Yeah, I mean, you can definitely think of taking it as a research problem, either in PhD or MTech, because this is one of the objective of sensitizing you, all of you, with the real world and industrial applications like that, so that you understand where actually it means. So the purpose gets served if I am able to sensitize you with the real world applications that we are working with.
And all the centers, I will send you all those Proteus programs also after this session. I'll send to all the coordinators. Okay, thank you for today. Thank you.